Hello, welcome to Law of Cosines. I think actually this is 5.4 for you guys. It might say 5.7, but it's actually 5.4. So let's go ahead and kind of cover what we're going to talk about as far as goals go. We're actually going to be able to, hopefully by the end of this, use the law of cosines to solve triangles, and then also be able to use the law of cosines to model real-life problems. This last one, Heron's formula, we're going to save that for the next lesson. Okay, so there are times when we may run into a triangle where we're given 3 pieces of information, but not the right pieces. In other words, we don't have enough to use law of sines. So for instance, in this triangle that we're given here, I'll just call it ABC to make things easier here. If I tried to set this up using law of sines, I would have the sine of A, which is 35, over little a, equals the sine of B, we don't know that, over 375, equals the sine of angle C over 400. And hopefully you realize we don't know one complete ratio, therefore we can't use law of sines here. So it sort of limits what we can do. So could we use right triangle trigonometry? Nope, there's no right angle. Can we use law of sines? And nope again, because we don't have one complete ratio. So we don't know an angle and the side across from the angle. All right, so that's why we can't use law of sines. So we need to use another approach. That other approach is law of cosines. If you really want to know how it comes about, I know we talked a little bit about that with law of sines, talk to me maybe in class and we can look at that. But our law of cosines really is the same thing. It's a pattern that we're going to follow. So let me kind of discuss this with you. So we'll use yellow for A, we'll use red for B, and we'll use green for C. So if I look at this, I'm just going to highlight everything that uses A with red. I'm going to highlight everything that uses, oh, and I did that wrong, B with yellow. Let me do that again. Everything that uses A with yellow. Everything that uses B with red. And then everything that uses C with green. And here's the biggest thing that we should notice. Whatever the side is that's by itself, that's the angle that we're seeing that's on the other side of the triangle or other side of the equation. So little a and big A are used in the same equation. If little a is on the left side of the equation, big A, the angle, will be within the cosine. Same thing here, little b and big B, little c and big C. And then the rest of this is just the same 2 things. So on the right side of this equation, we have B and C, B and C, A and C, A and C, A and B, A and B. And it's whatever we didn't use on the left side. So here we used A, so we have A squared. We're not using B or C on the left, so we use those here on the right. And then big A, the angle, goes where the cosine is. So that's the general pattern here. Now, that might seem a little crazy. It's going to get better once you actually try it a couple times. So let's just jump in and try it. So let me go ahead and I'll highlight things again after I label them. So let me move this over a little bit and let's label our sides and angles. Okay, so I'm not even going to use A, B, and C here. I'm going to use L, M, and N. So this would be little l, this would be little m, this would be little n. So let me go ahead and highlight them just like we did in the previous one. So I'll use red for n, I'll use blue for L, and I'll use green for M. Okay, now how do you know where to start? Well, you start with the angle that you know something about. All right, so in this case, I know that my angle is at L. Okay, so I have angle L. I'm going to write angle L all the way over here. Now, because I wrote angle L, on the left side of my equation, I'm going to have L squared. And around angle L, I'm going to have cosine. Okay, now the rest of this equation, we're going to fill in with the other two pieces. Now the other two pieces are m and n. So I will use green for m. So I would have equals m squared plus n squared minus 2 times m times n, and this will be times cosine of L. Okay, so that's what that looks like. Now I just need to fill in the information that I know. So because I knew that angle was 35 degrees, that's how I chose to use that angle. That was the only angle I was given, so I chose that angle. All right, so now let's fill in what we know. So I don't know L squared. I do know that little m is 375, so it'll be 375 squared, plus little n is 400, so plus 400 squared, minus 2 times little m, 375, times little n, which is 400, times the cosine of 35 degrees. Now what's really nice about this, notice that everything on the right-hand side of this equation has been filled in. So the great thing about that is I can type that into my calculator exactly like I see it. You can type it in one big expression and then find your missing, or just evaluate that right side. So go ahead and do that, and you should get this. Now guys, make sure that your calculator is in degree mode. If it's not, you're gonna get the wrong answer, okay? Now we have to take the square root of both sides in order to actually figure out the answer to this problem. So I'm gonna take the square root of both sides, and we're gonna get L is about 234 point, we'll say 3. So now I got an expression for, and that's in meters. I have a value for L. Now here's the thing. When we look at our triangle now, remember it says solve, so we have to find all the missing pieces. I know an angle and I know the side across from it. So I am not going to use law of cosines again. I'm going to use law of sines. It's a little bit easier and it's something you're more comfortable doing. Okay, so I'm going to use law of sines to find another piece of information. So I have sine of 35 over 234.3 equals, I'm going to go ahead and find angle n next, over 400. Now we have law of sine set up. Go ahead and pause the video, see if you can find your answer. Come back and check. You should get n is about 78.3. So now I have n. And then, guys, we can find the last angle by just subtracting the first two angles from 180. And we'll get that m is about 66.7. So the nice thing about law of cosines is that you really only should have to use it once when you're solving a triangle. Okay, let's try another one. All right, so now let's do this again. We're going to find all of the missing pieces. Now, there's a really important note at the top of your page. When finding an angle using law of cosines, you should always try to find the largest angle first. Now, that largest angle is going to be across from the largest side. Okay, so that's a key piece of information that we don't want to forget as we're working through this. So we'll go ahead and highlight again. Okay, I've got just highlighting the side and the angle across from it in the same color. And I'm actually going to go ahead and label my sides as well. So this will be little l, this will be little m, and this will be little n. So let's go ahead, and I think I highlighted that with the wrong color there. I needed to highlight the angle with green. There we go. All right, so let's go ahead and set up law of cosines. Now here's the thing. We don't have an angle, so we don't really have a frame of reference with which to start. So what we'll have to do here is figure out which is going to be the largest angle and start with finding that angle first. So we look at our three sides, and our largest side is little n. Therefore, we have to find angle n. So remember, we're going to put n, cosine of n, on one side of the equation, and then on the other side, we'll have n squared. Now, the rest of this is just filling in the other pieces of information. So we'll have L squared plus m squared minus 2 times L times m, and then times cosine of n. I got a little crooked there, but I think we're good. Now we fill in what we know. Okay, so I know little n is 12 feet, so I'm going to do 12 squared equals, I know little l is 10, 10 squared plus little m is 8, minus 2 times 10 times 8 times cosine of n. Okay, now some of this we're going to be able to kind of figure out by hand. So I know this is 144, this will be 100 plus 64 minus, so 2 times 10 times 8, that's 160 times the cosine of n. Now this is where we need to be really careful. Order of operations is so important. These two things we can add together, but we cannot add it to this until we know what n is, because order of operations says we need to do the cosine of n before we can multiply it by negative 160, and then we can add it to the 100 plus 64. In other words, it's going to look like this. Okay? Order of operations. We have to undo this plus 164, so I'm going to subtract 164 from both sides. It's going to give me negative 20 equals negative 160 times the cosine of n. Now I can divide by negative 160. And that's just, I mean, you could write this as a decimal if you want to. It'd be positive 1/8. I'm just going to write it as 1/8. Doesn't really matter. Equals the cosine of n. Now, this is when we need to be really careful, right? How do we find n? Well, it's just like what we did when we found the angles using law of sines. We're going to have to use the inverse cosine. So I'm going to use the inverse cosine on both sides. And what that's going to give me is whatever the inverse cosine of 1/8 is. Again, double check that your calculator is in degree mode. Okay, so we're going to get, let's say 82.8 degrees would be angle n. So now I have angle n, 82.8 degrees. Okay, good news is I've got angle n. Now I need to find the other two angles. I would not use law of cosines again. Okay, I'm going to go back to my triangle and I'm going to use law of sines. So if I go back here to my triangle, just zoom in a little bit here, I now know angle n and the side across from it. So I can start by setting up law of sines that says sine of 82.8 over 12 equals, and then I'm going to find the next largest side. So that's going to be side L, or angle L that we're going to find, because that'll be the largest angle. And to do that, I'm going to do sine of L over little l, which is 10. Okay, you've had lots of practice with law of sines. Go ahead and see if you can find angle L. Come back and check your answer. We should hopefully get 55.8 for angle L, and then we can just subtract 55.8 and 82.8 from 180, and you're going to get the other angle, which will be 41.4. So using law of cosines usually results in one time using law of cosines and then finding the rest of that triangle by using law of sines. And that's why we started with law of sines, because it is something we keep coming back to. All right, let's just do one that has to do with something that maybe a lot of you are familiar with, which is a baseball field. So a pitcher's mound on a softball field, and actually I'm talking about a softball field, sorry, is 43 feet from home plate, and the distance between the bases is 60 feet. It's still a little bit different than a baseball diamond. We have a figure to the right that illustrates this situation. What we want to find out is how far is the pitcher's mound from first base. So we're looking for this H value right here. Okay, so maybe it would be helpful if we kind of redrew that triangle a little bit larger, just so we can work with it. So we've got this information. We know that's 45 degrees. We want to find this. This is 60. And this is 43. We're calling this F, and we're calling this P. So this will be angle P, this will be angle F, and this will be angle H. So let's analyze what we know and what we need to find. So we know this angle, H. Okay, there's little h. We know this side goes with F. We know this side goes with P. So because we have angle H, we know that that's going to be on the right-hand side of the equation. Now, here's also what we know, guys. We can't use law of sines here because I don't know an angle and a side across from it right now. Okay, so I'm going to use angle H since that's the only angle I know something about. And we'll even write it like with the letter still in it. So we'd say angle H, and then on the other side of the equation we'll have little h. And then we just fill in the rest of this. Okay, so f squared plus p squared minus 2 times, and then we'll have f times p times sine of h. And then we can fill in what we know. So I do not know little h, so that's just going to remain h squared equals, so I know f is 43. I know little p is 60. Okay, so I can fill those things in. And then I know angle H is 45. And then once again, this is the easy way, the easy type of law of cosines, because you know everything on the right side. So I can just type all this into my calculator. So go ahead and type it all in, come back and check your answer. All right, and there we go. We got h squared equals 1800.32909. And again, to solve for h, I'm going to have to take the square root of both sides. So go ahead and take the square root of that answer, and you're going to get h is approximately 42.43 feet. So what we can say is that the pitcher's mound, it's always a good idea to answer the question, is about 42.43 feet from first base. And we could have used, and we use law of cosines for that. Now, those of you that play softball, you might be able to, tell me if that's actually a true statement. I don't know if those measurements were correct on the picture. I assume they are. But that's the idea. So law of cosines. Write it out based on the information that you're given, always focusing on an angle first. So figure out what angle you're going to use, either because you have an angle in your picture or because you need to find a certain angle first. Remember, we find our largest angle first. Once you have found an angle, if you're solving that triangle, then at that point you would want to use law of sines to find the remaining 2 pieces of information. Okay? Make sure you keep track of any questions you may have, and we will talk in class the next time I see you.